Very warm welcome to all of you on this Saturday morning. And this is a part of our ongoing College of Business webinars where we try and focus on something important, either from a technology perspective or a business perspective or from an academic perspective. And today, following closely on the heels of what we did last month we focused on generative AI. And I think that was a very interesting webinar for everyone, a lot of participation, a lot of questions, a lot of follow-up after the webinar as well. Today we are going to follow up AI with data. AI doesn't exist without data, and data and AI are such partners in crime, if you may, in terms of hustling the new frontiers for us. So we have an excellent speaker today, Harish Bhatt, whom I've known for many years. Harish has more than 25 years of experience in the technology sector. He has had experience in creating and modernizing data platforms, digital transformations and innovation services in the very fast-moving banking and fintech industry, the financials technology industry. He has directed global teams in leadership roles of Chief Data Officer, heads of technology, and Chief Engineering Advisor in organizations like Wells Fargo, Citigroup, and the most recent organization that he's a part of, which is called the Early Warning Company, which is actually the parent company of Zelle. Anybody has used pay methods from bank to bank uses Zelle, and that's the organization that stands behind it. And Harish is responsible for the data and technology architecture behind in that organization. So with that brief introduction, I'll let Harish take it from here. Questions, please put them in the chat. We'll run the questions towards the end of the talk. And Harish, over to you.
Okay, good morning, everyone. I'm just going to start screen share first, and yes, we'll get started. So good morning, everyone. So thanks, Vikram, for the introduction. I'm here to speak about various aspects of data. It's going to be very high level somewhat, but at the same time gives you a little bit of more real-time examples as well here. I'm going to be talking about data volumes and growth, data types and data stores, data processing and analytics, real life example, and workspace opportunities we have in this in the data space. Okay, so let's focus on data volume. So in the US today, approximately zettabyte of data is been captured and stored in multiple places. It's equivalent of 1 with 24 zeros around it. So you can imagine it's a huge volume of data, and these volumes have been increasing in recent years when compared to 2000s and 2010s kind of stuff. In last 10 years, it has increased dramatically. In next 10 years, it's expected to grow exponentially, and it's going to be multiple zettabytes. Even some projections indicate maybe in 20-25 years perspective, it can reach out to the yottabyte. So that will be 1 with 27 zeros. So this is how the volume is growing. So let's look at it. Where is the volume coming from? On a daily basis, we as a human beings in this world contributing to this data, just not one. It is from an enterprise perspective, from an individual's perspective, and our innovations perspective. So if you look at it from let's go from the left to right, and then go to the bottom. So we are creating content all of us or some of us creating the content one way or the other, creating, for example, our own websites is one aspect of it. Then Internet of Things. This is where we take an example of your electricity meter, making the simple readings and publishing it to your electricity provider. Of course, in the modern world, there is also things like your automated refrigerator, which can scan your supplies, and whenever it deploys, automatically creating orders and getting to the doors delivery. So these are all Internet of Things. So Then if you look at it, on the left-hand side, we're talking about digital transactions. So any purchases, any transactions we make with a bank or with any Amazons of the world, Netflix of the world, eh, all of them capture data. Those are considered as transactions. Then you have enterprise operations. Once you capture any data, it need to be get processed from operation perspective from the anything that every enterprise, even as simple as Amazon or any bank, they will take the data, they will make sure they can support your transaction. I mean, Amazon perspective, it can deliver the goods, and then there is a supply chain happening there. They all generate operational aspects of data. Similarly, banks can do the same thing. Then you have every organization has to comply with some rules, especially in the finance and the pharmaceutical/medical industry perspective. They have much more stringent regulatory requirements. They need to follow so they need to have internal audit and compliance procedures that comply to regulatory requirements. So that captures the data. Then finally, in the recent years, as well as upcoming years, we started to contribute a lot more data on a 5G and edge computing perspective. This is again anytime you leverage your mobile phone, traveling and maps and other stuff, captures the data, and any videos and audios you play, they're all capturing the data and publishing it to the single place. Similarly, the modern recent world, anytime you use any things like ChatGPT, it creates its own data, and your request, your inquiries also generate new data. So if you look at it, various aspects of it, there may be a lot more, but these are very notable ones which contribute in this data, which is 1 exabyte of data on a daily basis. So we have let's talk about data types now. When we capture the data organizationally, so there are some data which is very structured, some data is considered unstructured. Anytime when you talk about structured data, the data that can be represented in rows and columns, or any column can be represented as a number, string, or a date kind of stuff. Then on the other side, unstructured data, it cannot be represented within the rows and columns in a relational perspective. Essentially, these are the items where images, audio, video, emails, all of that fall into this category of unstructured data. Now, size perspective, 20% of the data is structured, 80% of the data is generally unstructured. This is based on a Gartner report 2022. And coming to the storage perspective, relational data requires less storage versus unstructured requires a lot more storage, because obviously there's a 20%, 80% rule, as well as in addition to that, it has a lot more. If you look at every image or every video or audio, the sizes are a lot more than a particular record that you store in a single row perspective. And based on all of this, also is easier to maintain structured data versus difficult to manage and maintain this. It takes a lot more operational aspects of it. So let's talk about data hosting. So this data gets hosted in multiple places. Let's start with the bottom part of the screen right now, mainly around this place. So any data, or every organization chooses to store the data in different ways. So let's focus on the on-prem. So which is basically enterprise hosting its data in the four walls of the enterprise, or even in the four walls of another hosting company. That is considered, but managed and maintained by the enterprise. This is considered as a local, it's considered the on-prem enterprise data. So let's look at it. Now, people have gone from based on the complexities of data, growing data perspective, they went from hosting an on-prem to try to do this based on sensitivity data, sometimes went to the private cloud, which is hosting, like similarly, the providers like AWS, Microsoft Azure, Google's of the world, they choose to host it in a private cloud, so that in the early days, they didn't know whether security aspects of the cloud So they try to host it on the private cloud. Even this is happening even today. So we'll talk a little bit more, come back and talk a little bit more on this topic. Then you have a public cloud. When people identify private cloud has become a bit expensive, then they try to use the public cloud. Public cloud is a concept where it is still a cloud like AWS, Azure, and Google's of the world. Now the network, the servers, the storage kind of stirred between multiple people, multiple organizations. That is considered the public cloud. Now, then there's a, between all of this, there is a concept of hybrid cloud came into play, where some of the data can be stored on-prem, or services can be stored on-prem and hosted on-prem. Some can be hosted in a public or private cloud perspective. So this is decided based on the what is more cost effective, more secure perspective. And these aspects, for example, typically anytime you host a service like your shopping cart experience, the software that runs, generally people try to host it in cloud, and based on sensitive data, they may choose to store all the data with an on-prem perspective. So that's the choice is made based on security, privacy, and cost aspects of it. So these are the concepts of, these are three different concepts we have within this. Okay, so we briefly talked about hosting. Let's talk about data storage. When you start to capture data, you need to store the data and organize the data based on your requirements or operational requirements as well. So typically, we have the concept of database, data warehouse, data lake, big data, lake house are the 5 different concepts. So let's focus on each one of them, why and when you use these types of storages. So database is basically anytime you want to do the relational database, and data is designed to be in rows and columns perspective. They're efficient to store, in the sense you can add the data, modify the data, delete the data, and retrieve the data. And then this is also suitable for when you want to transact in a real time, as well as when you want to retrieve and report data on the real time perspective. Generally, databases are good for up to 10, 15, 20 terabytes of data, but not good for large volumes of data. And the typical examples of this is Oracle, SQL Server, MongoDB, Neo4j, and DynamoDB. These are examples of the relational databases. Now let's go to the data warehouse. So these are designed to consolidate data from multiple stores, like there are multiple databases or multiple file storages, and and it is meant to generate a business intelligence and decision-making perspective. Typically, these are data warehouses contain, you tend to store up to 50, 100 terabytes of data generally in these data warehouses. These are good for reporting. And these typical examples of data storages are Netezza, Teradata, Redshift, and Snowflake. And the third is data lake. Data lake is designed to store large volumes of structured and unstructured data. It is flexible. Previous ones are considered schema on right, both of them, database and data warehouse generally. In the sense, your predefined structure well in advance. If you want to modify, you need to release a complete process of software release and other stuff. Whereas data lake can absorb the changes of data, structure of the data on the go. And it is scalable, low cost, and when compared to data warehouse. And it supports both structured and unstructured data, generally used for Internet of Things, social media, streaming data storage perspective. Now, big data is again, literally it is a big data. When you have the petabytes of data, generally you go for big data platforms, and they can store large volumes of data. They can churn the data, process the data very quickly, and it is generally it's difficult to process that kind of large volumes in data warehouse, data lakes, or databases perspective. And it supports when it is flexible in terms of that it can absorb a lot more volumes. It can do the velocity perspective and the variety perspective. It can support all of that. Now, the modern recent years, it is relatively a new concept introduced called lakehouse in the sense in the maybe last 1-2 years perspective, and it can support both. It can support large volumes of data, and it can support data operations of adding data, updating data, deleting data, and retrieving and reporting data much more flexibly. Generally, big data, for example, is good for simple doing the batch processing, and it cannot support real-time processing quickly, efficiently, whereas a lakehouse can do that. And it addresses basically shortcomings of your data warehouses, big data lake, and this lakehouse. So this is a modern concept, and there's a lot more adoption happening in the current years. Now let's talk about it, how the data gets originated and how it gets absorbed, consumed / processed, and when you derive value out of it. So you make a transaction, and as a user or a consumer, and that gets processed. That gets processed through a couple of steps in the backend perspective. Data gets collected, and then data gets cleansed and prepared for consumption for the business use. So data collection and the data cleansing and preparation are generally technology engineering functions. Whereas if you look at the rest of the 4 items listed here, which is the data exploration, data analytics, data visualization, data interpretation, decision making, are generally business functions. And these functions can be done by mostly done by the business with a little bit of technology knowledge. So this activities include ad hoc querying, canned reporting, dashboarding, self-service analytics, statistical analytics, and AI machine learning modeling perspective. Okay. Now let's go to the look at it. This is another view of because I mentioned about business with the technology, a little bit of technology knowledge can do these functions. So this slide talks about typical what kind of knowledge you needed from the business perspective. Ad hoc querying, you need to understand SQL. SQL has been in this for a very long time. It's called structured query language, and easy to understand. People understand it, learn it very quickly. Then you have canned reports. Here you need to understand SQL, but along with that, you need to also understand structure of the data, where the data is stored, how the data is stored. It is required for both canned reports and dashboarding and self-service analytic perspective. Examples of the tools that you have in this area are business objects, Tableau, Power BI, ClickView, and similarly, from the AWS perspective, we have QuickSight, Google perspective, BigQuery. These are the most popular common tools / utilities come into play in this area. Then last thing is AI machine learning. So here, along with all the above, you need a little bit of statistical knowledge. You need a little bit of understanding either Python or R. Python is generally my preferred choice and most popular choice in the market as well. It's easy to learn as well. This one comes with a lot of utilities and the frameworks as libraries that can be easily used. And whenever any change happens in the marketplace with AI, machine learning, new technology, new concept come into play, generally the people provide support for many languages, Python or Java, Scala, but generally Python has much more flexible, quicker software libraries available when compared to others. So IDEs and libraries perspective, IDE means interactive development environment perspective. Generally, there's some things like an Anaconda, then Visual Source, and then you also have libraries like PyCharm, TensorFlow, NumPys, SciPy kind of stuff. Then you also have in the cloud perspective, if you go, you have SageMaker from AWS, you have a Google as well as Amazon Azure ML software, library/tools, online interactive tools available for you to develop your models. So little bit of touch point on the AI perspective. Yes, data generate, whatever data you generate, that gets contributed towards the machine learning models. And the data that get generated from machine learning models gets produces new data that becomes internally leveraged again to generate new models in AI machine learning. In the current perspective, example will be you create a transaction, data gets cleansed, the model, sometimes the data available in transactions is not sufficient for creating a new models. Then you create a new features using the same data. These typically features means aggregations, some statistical values gets created based on the data. Then that data plus along with the transaction data goes into the creating the new machine learning models that gets trained, that gets executed, and that in turn again generates new data, and the new business opportunity gets created based on all of this stuff. Yeah, it's all good story, but this whole thing in the data and the AI space, there's a lot of governance and ethics being applied strictly by many organizations. I'm not going to cover a whole lot on the in terms of what it means, what it takes. It's out of scope for this data perspective, but we'll talk briefly on the data specific governance in the coming slides. Now, typical examples of machine learning systems or recommendation engines. Example will be when we start seeing the movie and they start recommending another movie for us. So basically Netflix or Amazon does that. And similarly, there's a product recommendations from Amazon. There's a Facebook content from content recommendations. These are all happening with leverages not only that what transaction you made, they also try to look at it, other historical data, and look at it and say, is anybody else done any other transaction similar to you, have a similar profile, geographic locations, or your patterns, they look at it, behavioral patterns, and then start to recommend something new. So this is a typical how recommendation engines work. Then you also have in the financial industry perspective, typically credit fraud detection, alerting happens, and preventing the identity theft. These are typical good examples of it. There are a lot more things happen in the financial industry, but these are typical examples we can see ourselves. Example will be when you try to transact with a credit card, they started to see the historical patterns and observe if there's an excessive credit card utilization or a location difference utilization, all of that leverage to detect a potential fraud, alert you on other stuff. So those are simple examples. Similarly, well-known thing for us is Grammarly, which can help with the writing, help with writing. And last thing we have seen it in which is obvious, which is self-driving cars, and Tesla will be a good example of it. So these are some examples of data contributing to how the new machine learning systems, AI systems have been coming to the market and how we're helping us going in the world. So this is I'm going to cover here about real life example. So this is example of typical large financial institution, how it operates, how the data works in this typically. So let's start with a simple example of organization. This is talking about the business organization. So there are departments in every organization. Every organization has goals. And now let's talk about it as a customer perspective. As a customer, you transact with your bank or a financial institution to do deposits perspective in the sense of savings account, money market account kind of stuff. Then you also interact with the credit cards. Then you also, some of us, we deal with loans in terms of the mortgages and personal loans. Then you have trading platforms, which is basically investment perspective. You would invest somewhere in some institution, trading, and then there is a trading and there is a treasury aspects of it. Whenever we transact with any of this, we generated data. That data stored locally, which is on the business unit level, in this case, sub-department level. So, and they leverage this data to generate analytics. And typically, these are required to meet the end of day reporting perspective. That also gets contributed to the higher level from department's perspective, which basically, for example, deposit and credit cards gets into the retail banking, mortgages and personal loans department, trading and treasury goes into the investment banking. So they also now start to gather data from your business units, now gets in the business at department level. They also store the data and they do the analytics required. So these are all required for the day-to-day reporting, monthly reporting, quarterly and annual reporting at different levels. Now let's look at a bigger picture of it. Now we saw the how the customer data we saw from previous slides. So first, two blocks, business unit and department, are exactly same as previous slide. Now, however, these data now gets contributed to the enterprise level. Now, enterprise now does a lot more data generation because typical functions in the enterprise perspective, finance and risk. Finance receives the same data that we have transacted with. And now then they calculate typically a profit and loss and a balance sheet, or the typical things they do. Then risk department gets a similar data, same data, and now they leverage that to calculate the potential risk in terms of the liquidity and other aspects of it. Then legal and compliance and regulatory departments also take the same data and try to look at it. Or for example, compliance perspective, anti-money laundering, they try to detect based on the accounts opened, based on your transactions made and other stuff. Then the regulatory department looks at it and say, are we capturing the right amount of data at the right places? And legal, obviously looking at legal aspects of the data and data utilization, where the data is. And information technology purely is a backbone supporting all this data growth and data capture and processing aspects of it. Then security, looking at from the perspective of, is the data in the right place? Is it leveraged in a correct? Is it getting leveraged correctly? And right people have right access, and making sure that's secure and making sure the privacy aspects somewhat been followed correctly, policies and other stuff. Then chief data office now comes into play. They oversee the whole process of data here. They just don't see one aspect of it. Now, if you look at it, every one of these departments have their data warehouses and they perform analytics on that. And finally, from enterprise perspective, all this data now gets into the generally big data platforms and they perform analytics. When they perform analytics here, generally these analytics at the enterprise level, it could be simple things that we talked about in the previous slides, ad hoc querying, canned reporting, self-service analytics, and machine learning models, and all aspects come into play. So if you look at it, now data is captured in multiple places, and data volumes keep increasing from subdivision to department to the enterprise level. Let's look at different aspect of department now. Let's look at that was previously what we talked about was macro level. Let's look at the micro level, how this gets. Typically, you transact, then there's a business process happening. This is where some kind of software running that creates a new transactional data that gets processed and stored. Then now that gets sent out to regional department on one side, as well as simultaneously being sent out to the finance and risk for calculations. And then finance and risk team will store the data, and they create another store from a department perspective and calculate some calculation. Similarly, in parallel to that, there's your data is also processing, getting sent out to the departments, business specific data warehouses, and all of them eventually merge into the big data platform. And then finally, all this data leveraged for business analytics. So we just talked about it. Okay. Now there is a yellow stars listed here. This, if you look at it now, every time when you want to process data, when you send data, generally there are data extraction, transformation, load processor run, and they also perform the data quality checks. They also perform, make sure the data is cataloged and data is lineages and established. So why is this data lineage is one of the key important aspects of in the financial industry. Anytime you generate a report and send out to the regulators, what they need to understand is, can I see they can come back and ask, hey, I see the number X. Can you show me the details behind it, how it's originated? So that means they need to trace this data back to the origination and transactions. This requirement started coming into play in 2008 when we had a mortgage crisis. This particular requirement came into play, where the government has requested every bank that every time you generate a report, we want to make sure we can trace it back to the transactions. So this is a typical, this is the must-have requirement financial institution perspective. So there's a lot more money has been spent in this industry for this, and for the data quality, data cataloging, data lineage perspective, along with the processing aspects of it. Now, this is another view. This is a little bit more macro view, purely from the data governance perspective. So in a typically large financial institutions, you do have a chief data officers, either at department or regional levels, and they're responsible for their data in a big data perspective. And then you have enterprise chief data officer, or recent titles are considered as chief data analytical officer, with a growing demand for analytics and AI machine learning perspective. This enterprise CDO or enterprise CDAO oversees all the functions that are around this. Now, there's one more another view of it, how the data works here. You start with the regional data business data officers, then globally you have the business level CDOs, and there is enterprise-wide CDO who oversees everything that is happening. So we've seen the data governance office. Now let's take a look at it in a typical organization, especially large financial institutions. You have multiple roles that support this whole data processing, data governance, and analytics aspects of it. You have a typically you have chief data officer, chief data governance manager, you have a quality manager, you have data steward, you have data quality analyst, data analyst, then you have the data engineers, then you have data engineering managers, and there is a initiative / program / project managers. So these are all the key roles that are kind of supporting this data processing and the data aspects of it. Let's look at a little bit more about what are the opportunities for all of us. Now, in the modern world, knowledge of data is a must for everyone, every discipline, because all data transactions and services, they rely on data. Then every business transaction generates a new data. Every organization wants to derive value out of data and to create new business opportunities. Every organization wants to protect their data to prevent from reputational damage, competition, lost business opportunities, and meet legal and compliance regulatory requirements. So if you look at it, we all have an opportunity in all these places. but we all need to understand the data, one way or the other. Now, let's talk about it. We talked briefly about various roles in the previous slides. So let's talk about why is what data analyst does it here, for example, and other roles. So in this case, the data analyst plays a critical role interpreting and communicating the insights derived from the data in a business understandable language. That's a very key. If you look at technology people and can interpret data, they can give some insights, but sometimes the value can be only given by the business people, typically data analyst does this. There's a data quality specialist. They're responsible for ensuring the quality of the data, integrity of the data, and quality and integrity is essential. If you want to derive good business value, your data has to be clean. Your data has to be accurate. So that's a must. In a data governance and compliance perspective, they are responsible for creating policies, procedures, processes, standards for managing the data effectively. Project managers, these are people manage, ensure the successful execution of all large or small data processing projects. And then come to the data privacy and security specialist. They are responsible for protecting data access, make sure that we have the right people have right access. They comply with regulatory requirements, and they also make sure they create procedures and processes as well. Now, let's look at it from the perspective of business, because from the perspective, another perspective, which is apart from the people who interact with the data, the titles we saw, opportunities we saw from the data perspective, there are other departments, other people in the enterprise. They also need to understand the data. Because, for example, if you take a procurement team is responsible for purchasing something new. Like typically, let's say they want to purchase a software or a product. Then they need to understand what kind of data are we sharing with them, what kind of data is they are going to share with us, making sure some of the data aspects of it, licenses aspects of it taken care correctly. In a legal counsel perspective, they're making sure the verbiage on every aspect of data utilization is accurate and it follows the standards and complies with the regulatory requirements. Compliance and risk team, they provide oversight as we talked about it. They establish the guardrails. Then your finance and accounting team, these are the people looking at billing, budgeting, and forecasting aspects of it. They need to understand what their data looks like. Operation services team, these are the key, critical people sometimes, and based on the which department they work on. If you take an example of these people, service operations team, typically they are responsible for all the ensuring all the transactions, business processes are working accurately from the back-end technology perspective. And then need to understand in and out of all the data coming in, how that's getting processed, how it gets eventually handed over to the right business teams. Then finally, this is a new evolution happening with AI machine learning and with generative AI coming into play, and with large language models have been in play. So these are, for example, take a generative AI and large language models. These are pre-trained models with, for example, ChatGPT kind of stuff. However, utilizing that technology, people are deriving a new opportunities in a niche, in a specialized business opportunities in terms of very niche. So they're looking for who can understand the business aspects of those and train these models to give the right value, right outputs for the people. For example, generative AI has been kind of looked at every possible documentation they generated. Potentially, they leverage a lot of knowledge available in the historical perspective and derive the value. But however, when you want to go to generate a new, like typical example would be you want to derive a value from for a medical technology, like for example, scanning of your heart, for example. And you need to have specialists who can leverage the data that you already historically gathered and train it to give the right value at the right time. So, and these are called prompt engineering people who can train this model in a specific way. It's a growing opportunity for people, and it's a new buzz. Now, my hypothesis, based on my experiences, the differentiation between business and technology started to blur in a day-to-day basis. However, the demand for specialized technical and business people are continuing to grow to build new specialized intelligence systems for sure. So that's my direct hypothesis. Let's look at it now. An executive level, what is expected for the new executives? Apart from every senior executive need to manage people, collaborate people, communicate, influence the management decisions. Apart from all of that, they've been expected to understand the business functions and knowledge, very good understanding of data, drive the new business opportunities, leveraging the existing data, and then significant inputs, including providing significant inputs, building the new AI machine learning model. Even at a very senior levels, this is becoming a requirement. So you can see every level, the importance of data understanding is obvious. Now, so far we have seen data volumes and growth. We talked about data types and data stores. We talked about data processing analytics, real-time example, real-life example, and workplace opportunity. At this time, we talked about all of this, and thank you for the opportunity here, Vikramji, and I will hand it over to you for any questions.
Thanks, Harish. So this was, absolutely on time in terms of the time that we had allotted. So there are a few questions. I'm just going to read them out in the sequence that I got. Chat is open for people who want to post questions. So the first question is, how does one know that there is enough data for an AI model to generate meaningful, useful insights? Sufficiency of data in some ways.
Right. So generally, when you want to train the model, you at least need to have, typical in data science, in a financial industry, what I've noticed is they want 6 months worth of data to train any machine learning model. This is a typical one. And the sufficiency is a decision made by the business teams and decided by some of the compliance and regulatory people. As I said, a typical 6 months, and they train the models generally with that data. They try to derive value out of it. They see if it is working as expected. If it is working expected, they move forward. Otherwise, they go for more data.
Thanks. So you were saying typically thumb rule is 6 months of past data for building predictive AI models.
Typical, yes.
Next question there is more on the generative AI side, and this question is ChatGPT an example of data-fueled AI ML system?
Yes, exactly. So this is ChatGPT is purely based on a lot of historical publications, historical data collected, digital, transformative, medical, every aspects of it. It is based on that data.
And data sets is the most important part of ChatGPT. So if the data sets are not there for the questions that you're asking, then ChatGPT will perhaps fail in giving you the right kind of answer. So, we rely on it, but the data set is the most important part of what underlies ChatGPT. The next question, again, we're getting a lot of questions around AI and data, which is what one should be expecting. It says, in light of advances in AI, is database design, as we traditionally know, such as relational database, going to become obsolete? Relational database design meant faster access at a lower cost, at cost effectively. With AI and huge competing power available to all, is it still relevant?
So relational databases are still relevant because you still need to process transactional data. Basically, in the typical uh, digital world, you still need to interact with, for example, like shopping carts or your banking transactions. They all need to be transacted in real time. So the data will, there's going to be relevance of relational database for some more time. So even it may change, but at this time, it is relevant.
Okay. The other question that is there is because of privacy concerns, the person is making a statement saying cookies will be soon a thing of the past. Because of privacy concerns, cookies will be soon a thing of the past. What innovations are likely to replace them?
So cookies are not absolute at this time. Basically, first-party cookies are still allowed. What is not allowed is third-party cookies. That's one thing. In a modernization perspective, your biometrics passkeys will become much more relevant in coming. It's already relevant, and they will become more prominent going forward.
So you're saying biometrics may be the way to look at personalization, but then there are issues related to biometrics also in terms of if that gets hacked, then you can't replace that, right?
Yes.
Okay. The next question is, let me just make sure that I get the chats organized correctly. Okay. What is the difference between GPT versus traditional AI ML, and which one will become dominant in the future? I guess the question here is more between Gen AI, generative AI, and predictive AI. I'm assuming, but
Yeah.
the
So I
question is,
think they both play a role. Generally, you leverage ChatGPT for your um, advanced. They have relevance from the perspective of uh, the transaction, communications, the conversational aspects of it, whereas your other traditional AI models will continue to exist to derive again from a business enterprise perspective. For example, you want to detect a fraud. So typically you would continue to use that's not going to change immediately, but obviously the new machine learning models coming in future with based on this large language models and other stuff, they may replace, but not at this time.
yeah, and I think we got a clue of this also in the last month's webinar. If I could just add here, I think the first couple of slides that Alok Pant had used was to define ChatGPT as a part of this whole generative AI, systems which generate new content. So the new content generation is the differentiation between ChatGPT kind of models and predictive AI. But in predictive AI also there is a new data being generated, but the content is you're basically using existing data to create a prediction, based on what the future might hold. Okay, just to add on in terms of what perspective we learned from the last webinar. Okay, the next question, Harish, is that in the rare instance where there is an anomaly in data, I don't think it's rare, but the question is in the rare instance where there's an anomaly of data, is that just thrown away, or is it possible? Is it collected for possibly new collection of data or later use for the company? So basically, whatever doesn't work, does it get thrown away, or there's a way to reuse it?
So in my personal life so far, no data gets thrown away. Number one. Number two, if you do have a data quality issues, there is an emphasis by most of the enterprises to clean and correct it. That's another aspect of it. And the billions of dollars, and especially in the finance industry, billions of dollars, not billions of dollars been spent for the data quality.
And that again underlines what Harish has been talking about, or the kind of employment opportunities that exist just in the data space, right? Which are both technology oriented and business oriented. So the mindset that we might have that all data is technology oriented, that's not strictly true. Okay. The next question here is, can I use AI to handle a database that I have on my PC? I don't know what he, maybe
Yeah.
Mohammed, you want, yeah, go ahead.
No, I can only talk about it. You can run your AI models um, based on a type of a machine you may have in your laptop. I think the training AI model is most likely not easy or possible in your local desktops, but you could get a trained model and run against your services that you may be hosting. So that's very common.
I guess it'll also depend on the volume, right? So yes, you can train, but what kind of output you'll get will be based on the volumes that you have on the database on your PC. Would that be fair?
Yes.
The next question is, do you have any suggestions on some successful case studies of businesses using data to drive growth and innovation? I don't know whether we have another few hours to talk about this, but go ahead.
Yeah. So I think a simple example I would say is medical field is leveraging that to derive value. For example, that nowadays in the medical field, they can read all your ECGs and other aspects of it and tell you what's your possible um, risk with you getting a heart attack, for example, as simple as that. So today, there and as well as once ECG is scanned, they kind of process it through the AI machine learning models in some places and come up with the reports that indicate these things. So that again, this is one simple example I'm giving you, but there is a lot of examples deriving the machine learning. For example, I
Maybe
can
you
also
could
talk
give,
about in a financial industry.
right.
The simple thing is going to be identifying a person defaulting from paying the loan. As simple as that is a business value. Preventing, basically, that's basically where you apply for a loan, it kind of runs the model, tells you risk attached to that person giving the loan to the person, and stopping from either giving them the loan or giving the loan, right? So that's a simple example of how the AI kind of adding value to the business.
Okay. And Sabita ji, this is a question from David because you got David Townshend there. Is that? Well, I'll just read the question. So, how can we integrate the teachings of data sufficiency, privacy, compliance, and innovative AI technologies into future curriculum? Oh, this is a MIU question. Okay. So again, I'll just read it out so that everybody knows what the question is. They're seeing it on chat. Is I'm hoping, okay. So yeah. So how do we integrate the teachings of data sufficiency, privacy? So basically everything that we're discussing here, how do we put it into the future curriculum of MIU to prepare students for rapidly evolving landscape of MIU? That's perfect question, David. So I think some parts of it are the webinars that we are doing, but I think there's a lot more to be done and good input that we will take as we plan ourselves further. Thank you. Um, Andrew has a question. Will AI replace non-technical data roles in the future? Will AI replace non-technical data roles in the future?
I don't think so. Yes, there's a lot of concern being raised by a lot of people with a lot of advancements in AI, but I don't think so because they all need further assistance to perform in a way they perform. There's anything that is coming in the market, we also look at it as they're going to assist us to perform operations, perform our duties as like roles correctly and efficiently. And they also need to be monitored and managed in a way they can be. For example, a good example of that is prompt engineering is a classic example. You need to give some intelligence to the machine learning model from a business aspect to derive a better functionality of that. So I don't think we should worry about that.
And again, I just want to add on, it will be worthwhile for Andrew, this is a question that you had asked, worthwhile for you to go and watch the webinar that we did on AI. And one of the takeaways of that webinar was that AI is not likely to be a job killer. It'll actually be a job creator, except that the type of jobs will be slightly different. But it's a net job creator was the takeaway talking to a CEO of a company who runs an AI consulting organization. So they consult companies of how to deploy AI, and this was his takeaway based on last month's webinar. So it might be worthwhile to go and just have a look on it. Maybe this is the last question. I'm just looking at the time. Saad's question is, okay, there's maybe one more about after that. Okay, last two questions, and maybe we can stop there. So Saad's question is, how can governments and businesses collaborate to mitigate the negative impacts of AI on job displacement while maximizing its potential to create new employment opportunities? So maybe the question should be not about governments, because clearly Harish and I don't represent governments, but how do businesses collaborate to mitigate the negative impacts of AI and job displacement while maximizing its potential to create new employment opportunities?
So I think, I mean, if you read any of the, if you hear the financial industry perspective, if you hear the Jamie Dimons of the world. So one of the key important thing is they're talking about they want to adopt the AI machine learning, but they're talking about the efficiencies and aspects of it, and they're talking about generating the new opportunities through that, rather than they're looking at wrong differently at this time.
Yeah. And again, Saad, I'll still point you to last month's webinar on jobs and AI. I think that was covered, almost half the webinar was around that topic. So I would strongly recommend to go back and look at that. The last question from Lenia is, can you speak about policy, especially around privacy, security, I'm sorry, as protecting users and the public at large from abuse of AI ML? Okay.
So this is a major industrial debate going on, and there is a lot of work going on at this time to protect the privacy and other aspects of it. If you look at European Council has released a significant ruling and created a policy for it. US has not yet done that. There's a lot of work behind the scene going on. There's a big discussion going on with the privacy and ethics aspects of it. Europe is much more he's ahead of the game when compared to US.
And that has been true on privacy and data concerns from day one. Europe has led the policy making aspect on this subject. Okay. Again, there's a question from David. What are the greatest cutting edge technologies that can help individuals leverage their existing business or industry? What are some of the greatest cutting edge technologies that can help individuals leverage their existing business or industry?
I mean, cutting edge means is again, AI machine learning is one of the cutting edge.
Here, the context is AI and data, right?
So AI machine learning is definitely cutting edge that we should all leverage with every industry is leveraging, and we should all look into that. That's one aspect of it. Then other things are happening in the innovation perspective of your Bitcoins and other stuff that's still kind of taken a lower priority when compared to AI machine learning. And there's other aspects of it is augmented reality. And in all of these aspects of it, AI machine learning is kind of leading the pack in this innovation perspective.
Yeah. And maybe just add to that, what we will do is on that webinar website, when we were doing the webinar last time, after the webinar, some students collaboratively got together and curated a set of AI tools generative AI tools for different areas of business. And that list, I think it was, I think Sangeeta Datta had taken the lead on that. She's a part of the PhD cohort, but it should be available to everybody. We'll figure out how we can post it on the webinar website without causing any privacy concerns. Okay, so we'll do that. So it's about 12 to here in Fairfield. We'll start wrapping up. Thank you very much, Harish. This was really, listening to you on data was like, real life examples. And I know you were holding back on some of your real life stories because clearly there are strong um, uh, anti-competitive. You don't want to give away what's happening in the current scenario with the people that you work for. So I completely understand that and respect that. But this is clearly the future in terms of people call data the new oil, right? It is the one that's going to differentiate. Silently, it's happening, but it's happening at a very, very rapid pace. Thank you all for being a part of this and for the lively question and answer. And we'll post the recordings of this on miu.edu/cba/webinars. And all of you have a great summer. And for those who are graduating, congratulations and wish you the very best in your future endeavors. Thanks, Harish. Thank you all. Take care and bye.